Hi, in this lecture video, I will be discussing scientific notation. So first, we'll go over the reason why we have to learn scientific notation here in chemistry, and then we'll go over a description of what scientific notation is, followed by how to use a scientific notation and changing between decimal number and to a scientific notations. And lastly, we'll go over how to correct for some of the common mistakes that we've seen when students write scientific notation. And now let's get started. So here in chemistry, we have to use scientific notation. And yes, I said it, we have to use it. And the reason why is that in chemistry, we deal with very big and very small value. And whenever we deal with very big and small value that have a lot of zero in them, it's actually very easy for us to miss a zero or to add an extra zero when we write those values. And now we all know already that by leaving out a zero or adding in an extra zero, we can change the value significantly, right? So therefore, we have to use scientific notation because by using scientific notation, it allows us to write this very big or very small value right here easily. So that way, we're not changing the value unintentionally. So that's the reason why that we need to learn and use scientific notation in chemistry. Okay, so we can write the following. And because again, here's an example right here. A 500 milliliter water bottle has this much water molecule in it. And you can see this is a really big value right here, and look at it, it's very difficult for us to see how many zeros are in it. And if we have to copy this value over and over again in calculation, it does become really time consuming. So it's time consuming to write. And second, it's very easy to miss or to add an extra zero or maybe more. And here's another example right here. It takes this much of a second right here, 0.00000000333 seconds for light to travel a distance of 1 meter. So that's a very small value right there. However, this very small or very big value right here are very commonly seen in chemistry. So that is again the reason why that we have to use scientific notation in chemistry, so we can report very large or very small value easily. And our scientific notation consists of two parts. One part is called the coefficient part, or also referred to as the decimal part. So in this case right here, I'm using A.B.C.D, and A.B.C.D here would be values. And then followed by this multiplication sign right here. And then the other part right here is 10 to the n, where this part right here is referred to as the exponential part. So two parts to describe one value. And please remember that when it comes down to a scientific notation, it does one single value, but it consists of two parts in it. Now they're not equal to two parts multiplied by each other, so it's not this multiplied by this. Technically, the two parts are supposed to be this one single value, but mathematically it is equal to this two parts right here multiplied together. However, it should be treated as this one single value. So now let's describe the coefficient part first. So the coefficient part right here, it has to consist of value that range from 1 to 9. So the range for this, so range from 1 to 9. And it cannot be greater than 10. Okay, so cannot be 10 or greater. And this is actually a very common mistake that I have seen with a lot of scientific notation, in which that the coefficient part is like 10, 11, 12, or any of those values, or smaller than 1. And it also cannot be smaller, cannot be smaller than 1. So but it has to be between 1 to 9. And now moving on to the exponential part. So this n right here, this is the exponent, and it has to be a whole number. So it is a whole number, cannot be a decimal number, and it can be positive or negative. The more positive it is, the larger the value, and the more negative it is, then again it will be the smaller value. And now let's go over how we would use a scientific notation. So how to change a decimal number to a scientific notation. So the first step is to do the following. First, locate the decimal point. There are two types of decimal point: the implied decimal point and the specified decimal point. The implied decimal point is basically the decimal point that implied to be toward the end of the number, but it's not something that's been written out. However, it is implied to be toward the bottom after the last digits. So normally that is something we call the implied decimal point. And the other types of decimal point is the specified decimal point. Despite the specified decimal point is the one in which that it is being written out. So these are the two types of decimal point. And yes, in chemistry, they actually have different meaning to them. So first, we need to locate them first. And once we have located the decimal point already, we will then move the decimal to the left or to the right to make sure we get the coefficient range from 1 to 9. So if the coefficient is 10 or greater, we will have to move it to the left. Versus if the coefficient is something that is smaller than 1, then now we have to move it to the right. And now, depending on whether we move the decimal to the left or to the right, and how many times that we move it. So if the decimal is moved to the right n number of times, the exponent will then be a positive n. Versus if the decimal point is moved to the right n number of times, then the exponent will then be a negative n. So this is something that we need to remember, and so it's actually be much easier for us to remember this by making sense out of this. And here is how it goes. When we move the decimal to the left, we basically making the value smaller, right? So therefore we have to increase the exponent or give it a positive exponent, so that way we can compensate for it. Because in scientific notation, consider this two part right here. If we were to increase the coefficient part, we have to decrease the exponential part. So that way, in the end, it will balance out and the value remain the way it is. So this is why that it makes sense that when we move the decimal to the left, we make the value smaller. We have to give it a positive exponent, so that way we can compensate for it. And similarly, if we were to move the decimal to the right, we'll be making the value become larger. So therefore, we have to give it a negative exponent, so that way we can again compensate for it. And now let's try a few examples right here. So with the value that we have seen above, so 1672, and here there's a lot of 0. So the first step is for us to locate the decimal point. So here in this case right here, the decimal point is implied to be right here. So we do not have a specified decimal point, but we have an implied decimal point in this value. And right now it is to the end of this 0. And in this case right here, we have to move this to the left, right? And we have to move the decimal point, so that way it is between the 1 and the 6. Because we have to move it to make sure the coefficient part ranges from 1 to 9. In this case right here, we have to move it between this 1 and this 6. So now let's figure out how many times we have to move it. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have to move the decimal point to the left 25 times. And once we have done that already, we have 1.672. And now followed by the multiplication sign, and now 10 to the 25th. So that's how we will be able to convert this into the scientific notation. Now you would then notice the following. When we convert this value into the scientific notation, we are not carrying this 0 over right here. And so the reason why we do this is because this 0 right here are not significant. And that is a topic that we'll discuss later. And now moving on to another example. So here is another value we have seen already. And now let's convert this into the scientific notation. So in this case right here, there is a decimal point right here. This decimal point right here, it is specified decimal point. Not like this 0 that we have seen here, which is the implied decimal point. But then in this case, it is the specified decimal point. And now we're going to take it and we have to move it to the right? And we have to move this decimal point to this location right here. So that way, our coefficient part would be range from 1 to 9. So in this case, we have to move this 1, 2, 3, 4, 5, 6, 7, 8, 9 times to the right. And now we have 3.33 times 10. And in this case, when we're moving it to the right side, we have to give it a negative exponent. So now negative 9. So that's how we can change a decimal number into a scientific notation. And likewise, we need to be able to change from a scientific notation back into a decimal number or a decimal notation as well. So this is the opposite of what we have done on part A. So here's how we would do it to be able to change from a scientific notation to a decimal number. First, take a notice of the exponent. If the exponent is a negative value, then we move the decimal to the left that x number of time and add in 0 in the middle if necessary. Versus if the exponent is a positive x, we will then identify the decimal point and now we move that decimal point to the right that x number of time depending on what the exponent would be. And again, we'll be adding 0 in the middle if necessary. For an example, so given this value right here, this scientific notation, let's now convert this into a decimal number. So in this case right here, we will then see that the exponent is a negative value, negative 5. So in this case right here, we have to move our decimal to the left 5 times. So moving it 1, 2, 3, 4, 5. And now put in that decimal. And now we have to add 0 in the middle. So 1, 2, 3, 4. So depending on how many times we place it, we now have to add in that much 0. In this case, we have to add in 4 0. So this value become 0.000060245. And there you go. Now we can add in another 0 before the decimal point, which is fine. Or we can, if we leave it out, that's fine as well. And now let's try another example. Here is a scientific notation. Let's now convert this into a decimal number. So in this case, we have a positive 7 exponent. So now we're supposed to move the decimal to the right 7 times, right? So 1, 2, 3, 4, 5, 6, 7. So that basically means we have to add in 2 extra 0. So in this case, this equal to 1, 7, 8, 9, 7, 8, 0, 0. And right now, whether to put the decimal point on this value or not, that is something that we will discuss later. Okay, but in this case right here, we will not be including this decimal point, and we'll go over why later when we discuss about significant figures. But there you go. So that's how we can change from a scientific notation into a decimal number. And next, we also need to be able to correct for a scientific notation when it is not written correctly. And because this is actually a very common mistake, so therefore I'm including this section right here to teach students how to identify the problems in some of the scientific notation and make sure we know how to correct for them. And so notice the following. In a scientific notation, the coefficient part has to range from 1 to 9. And this is a very common mistake right here, in which that I have seen the scientific notation that are now 10 or greater. And that is a very common mistake. So anytime that we see a scientific notation that is not written correctly, we need to correct for it by doing the following. We have to move the decimal to the left or to the right to get the coefficient to range from 1 to 9. Because a lot of time, the reason why a scientific notation is not written correctly, it is because the coefficient do not range from 1 to 9. So this is why we have to move it either to the left or to the right to get the coefficient to range from 1 to 9. And if we were to move the decimal to the left to correct for it, you will then have to increase the exponent or add on to the exponent x number of time, depending on how many times we move it. And similarly, if we were to move the decimal to the right x number of time, then we will then decrease or subtract the exponent that we already have, that x number of time. And the logic for this is something very similar to what I have discussed previously. When we move the decimal to the left, x number of time, we essentially will be making the value smaller. So this is why that we have to increase or we have to add to the existing exponent x number of time to compensate for it. So that way the value will remain the way it should be. And similarly, if the decimal is moved to the right x number of time, essentially we are making the value bigger. And to compensate for it, we have to decrease or subtract the existing exponent x number of time. So that way again it can remain the same. And now let's try a few examples. So in this example right here, we are given some incorrect scientific notation. For example, here in A, 45200.1 times 10 to the 4th. Now, so I sure hope why you realize this is an incorrect scientific notation and you would not be writing this kind of scientific notation because technically speaking, it is incorrect. And the reason why it is incorrect is when we look at this coefficient part right here, this is 45,200. This is not from 1 to 9. So therefore, it is wrong. So now we have to locate the decimal point, and in this case, this is where it is. And now we have to move it to the left, right? We have to move it to the left until the decimal point locates between the 4 and the 5. So in this case, we have to move this 1, 2, 3, 4 times to the left. Okay? And now this becomes 4.520001. And now, times 10. The existing exponent right now is 4. And as we move this to the left 4 times, we're making this value smaller. So therefore, we're supposed to add 4 more to this existing exponent. So in this case right here, it will then become 8. And now that will be the correct scientific notation. And now let's try the second example. In this case, we have 0.003878 times 10 to the negative 7. So it is an incorrect scientific notation because the coefficient part right here is much smaller than 1. And now we know that we have to convert this, to move the decimal to the right to make sure we can get the coefficient to range from 1 to 9. And in this case, we have to move the decimal to the right 1, 2, 3, 4 times. So we're moving the decimal to the right. We're making it bigger. And because we're moving it bigger, we're supposed to basically subtract the exponent, right, to compensate for it. So in this case right here, the starting exponent is negative 7. And now we have to subtract because as we move the decimal to the right, we're making this value bigger. So we have to take the existing exponent and subtract how many times that we move the decimal point. In this case, we have to subtract 4 from it. And negative 7 minus 4 would then equal to negative 11. So therefore, the answer would be 3.878 times 10 to the negative 11. And there you go. And on this last part right here, we want to make sure that you know how to enter the scientific notation on your calculator. And so because each of you have different types of calculator, so therefore I will not be able to teach you specifically how to enter the scientific notation on your calculator. So this part is up to you. So based on the calculator that you have, you need to look up the instruction how to enter its scientific notation, and then list the instruction and give 2 examples on this page right here that I have provided. And this is the extra note that I expect to see when you submit your notes to me. And on below here, you will find 4 practice problems. And as you study your notes, then I expect you to also complete this 4 problem as well. So with the note that you turn in to me, make sure you have all of the answer worked out in all of these boxes. And these are basically very much similar to the example that we have covered already. So I don't expect you to encounter much difficulty with these problems. So please do them and submit them along with the notes that you will be turning in.